Assalamu alaikum wa rahmatullahi wa barakatuh. Alhamdulillah. I live another day today to be able to pursue my attempt in producing educational videos like this. Today is the 2nd of Rabiul Akhir, 18th of November, and still we haven't really get away with COVID, so we continue this video, hoping that students, academicians, and staffs, personnel whose work is related to matters which involves environmental management be able to perform their duties at a higher level, despite the constraints that we have in this so-called pandemic movement control. So, Alhamdulillah, thank you, YouTube, thank you, subscribers and viewers. Today, or this video, will attempt again to link safety, health, and environment, whereby my knowledge on safety and health concerns their what they call technical know-how is really limited. So I hope if you are SHO personnel, industrial hygienists, or health safety experts with experience, please do top up what I have left behind in my explanation. Thank you very much. And I wish all blessings from the Almighty Creator upon you. Now let's take a look at one picture here, whereby this picture was taken way back in 1998. If I'm not mistaken, I was undergoing training on Isokinetic Stack Sampling, and this is the assistant to my supervisor who performed stack sampling a bit in a bit different way. They are able to perform isokinetic stack sampling around bands of chimneys. Now, that's not the issue for this video. They are using equipment, and I believe this is the Anderson model. Now, this activity is a common activity now in this country. Requirement for stack sampling is enormous, and with the apart from the perhaps EIA approval terms and conditions, there are also other kinds of written approval issued by the authority requiring premises or related premises who have air impurity discharges through their stacks or chimney to perform periodic stack sampling of several air impurities parameters such as dust, sulfur oxides, nitrogen oxides, and perhaps even heavy metals, and perhaps also inclusive of acid mist, etc., depending on where they belong in the clean air regulations of third schedule. Okay. Yeah. Okay. Third schedule or third schedule. All right. Never mind. Now, this is an activity normally in Malaysia, the whole equipment, especially the sampler, the probe, the entire set, and umbilical cord is being carried up into the stack part, whereby there's a monkey ladder being provided up to the platform where you can find the sampling ports. And in this country, it is very, very high, and all these scientific equipment, they are sensitive, they are vulnerable, and our personnel, I should call them the heroic technicians of isokinetic stack sampling. They have got to bring it up there, 60 feet high, 40 feet high, walking on a platform which has been around more than 10 years. Some are even corroded, and perform this test. They have got to stay there because they have got to take sampling not one point. They have got to calculate the traverse points and determine the number of sampling points depending on the chimney diameter, the probe, the nozzle size, selecting all based on certain criteria. So it is a hazardous job. Now, after there are so many environmental aspects involved in this activity, and I just take one of them. Let's take a look. Yeah, this is rather not popular because I've been doing audit for certified companies who have done isokinetic stack sampling, but I seldom see this. And well, it depends on how much we understood this. I'm not saying I understand everything, it's just based on experience. So use probe brush as being what they call one of the output environmental aspects. After the work is done, the technician, the team of people actually has got to clean up the probe itself before packing it back for the next job. And because we have to avoid, you can check the manual, we have got to avoid any contamination due to hardening of some of the tar residue that might be collected through the probe, and we've got to make sure it's clean and dry. And when we get back to the lab, we've got to wash it and clean it again, super clean, before it is approved for the next job, because we got to ensure no external contaminant. We've got to make sure our results, data from our work, is accurate. And the reason why we choose isokinetic stack sampling is because this is claimed to be the most accurate stack sampling methodology that US EPA adopted. And then the entire world follow this particular method. Never mind. Now let's take a look how this use probe brush would affect safety. These are equipments with not much ergonomics, and it could pose, well, let's put it right down here, it could pose some form of hazard to people when the brush is laying around not managed properly. And the fact that this activity, how it poses a concern of safety, is because of the nature of the isokinetic stack sampling equipment itself. You take a look, some of the, it involves glassware, it involves metal structures, tubes, and some are quite sharp, some are bent, and the end of it are, when it is hit by human, it can cause injury. And on top of that, especially in Malaysia, the stack, even though it's 60 feet high, it is very hot. I think it's the second best place to have sauna. It is very hot, and people working up there, our friends, technicians from Isokinetic Stack Sampling Contracting Company, they are working sweat out up there, and dangerous, because another potential hazard to safety for this work is they are usually working at heights. And safety health officers, you know this better than I do. And despite that, little concern is given to these technicians based on the fact that they are actually sampling hazardous materials. The discharges from the stack, despite it may comply to certain regulatory limits, but the presence of hazardous air impurity is still a hazard to human being, and it can cause potential hazard or potential risk to human in the form of health. okay, health concern, and they could be inhaling, they could be having some form of injury while working at the stack, because I have been on well, in my those days when I was younger, I climbed stacks myself. And there was one stack, it was about 60 feet high, and I was looking down at the platform and I saw the connector. It was all welded, the platform is welded, the base plate of the platform is welded to the outer rings frame structure, and I saw rust. And I saw rust, and I tell myself, what in the world am I doing on top of this rusty plate and the 60 feet below me? So I don't do many, because after that I have altophobia. And when the wind is blowing, you are on that stack, you could feel the stack is swaying. Serious. 1 inch left, right, or around. You can feel it. Well, if you have done this, or you are in the construction company, you might think this is nothing. Yeah, for me, it is something, because I'm not a keen climber. My children, they like to climb mountains, but not me. Okay, so there's a potential risk of falling down, and also, yeah, you can get intoxicated for the inhalation of some probable fluctuating airflow containing some form of hazardous materials through the stack. And you're up there, you're just right at the mouth of that stack hole. We call it sampling ports. You could smell it, and you got to sample it. And when you got to sample it, you got to adjust the probe alignment, literally. Okay, and you got to be there sampling. And I hope our friends working as technicians in stack sampling be given luxurious insurance premium, please. All right, this is human health, this is human life, and our friend is doing a job in favor of the environment. And when there is injury when working, as you could see, it can lead to environmental impact in the form of medical waste. All right. And most of it is actually transferred elsewhere for perhaps incineration in a medical incinerator, and that will cause air pollution, soil contamination as the subsequent eventual final environmental impact. And this activity, of course, it is also, in terms of environment, this brush could also pose hazard to human. Even when we are washing it, we are trying to clean the brush, it still contains residual and active impurities, environmental pollutants, which can be airborne and which can be inhaled, and we can be affected just by doing that work, cleaning. All right, the probe using the brush, and that would be bringing some safety issues as well. Some of it are sharp. We might be over squeezing the brush, and we might hurt ourselves or finger, because when we got to clean it, we really got to clean it, and we got to handle it with care. That can cause injury, and injury can cause the deviated deviation in how we perform our work as far as the safety SOP is concerned. That can cause accidents and can cause deviation from safety SOPs, and thereby producing environmental aspects in abnormal situations. Remember, normal, abnormal, and emergency, probably even emergency situations, and can cause eventually an environmental impact, perhaps soil contamination or air pollution. All right, now let's take a look at this one. I have only a few samples of environmental aspects, three of them. Let's discuss environmental management system. Okay, let's take a look at the first environmental aspect that we chose. Use probe brush. Okay, you'd like me to change the color, maybe, yeah. Now, used pro brush, this is output. So what sort of environmental impacts would it cause? Since it is an output aspect, we will have got to look at the downstream of its life cycle. All right, and the downstream of its life cycle is where the used probe brush would interact with the environment. How? It may be disposed as solid waste, or if it is an instrument related to environmental hazardous emission, or contaminated with some hazardous or toxic chemicals as in the form of emission, it can be rendered schedule waste, maybe, but I hope not, because we can clean it up. But never mind, let the agency decide that. Now, the downstream, it will interact with the environment when we dispose it in the bin, assuming it's a non-scheduled waste. It's an ordinary bin, thus bin or rubbish bin. Then it's collected and loaded onto waste disposal transport and bring it all over to the perhaps municipal landfill or sanitary landfill, and there it will be dumped with heaps of other sort of waste already waiting for it there, and therefore it will interact with the environment, rain and shine, and with all other kinds of waste which is partially degraded, which is degraded by the virtue of weather, which get rusted, and they will interact, causing mixture of hazardous substance and thereby causing soil pollution. And in heavy rain, maybe it's just one conspiracy theory, okay? In heavy rain, maybe the entire garbage dump site will be washed with water, and those in liquid discharges, which are normally results of degradation, chemical degradation, biological degradation, would be seeping into the ground or flow with the surface runoff to perhaps the nearest ditch, or perhaps monsoon drains eventually into rivers and causing water pollution. That is how the probable interaction between the use probe brush downstream its life cycle perspective and causing environmental impact. Now, another, well, seldom addressed material as far as environmental management system ISO 14001 is concerned is this particular material, which is a glass thimble filter used for the Isokinetic Stack Sampling equipment set. Does it interact with the environment? Yes. Is it an environmental aspect? Yes. Why? Well, let's take a look. It is an input environmental aspect to this activity, a fresh glass thimble, unboxed, unwrapped for use. And what is it made of? Special glass. Why is it an environmental aspect? Because in the manufacture, in the production of the thimble filter involves interaction with the environment upstream of its life cycle. How does that happen? Well, the thimble filter is made from silica, it involves glass, silica, it involves some other petrochemical products, blend together and mold it, and maybe blow mold it into the shape in a mold, molding, a kind of injection molding, but using silica and also other related material. And all these are materials whereby the interaction to the environment is all these material were being extracted from environmental resources, from mining, and from petrochemical production, from oil and gas, from crude oil. Eventually, the more demand for this material, including glasses, would cause the final environmental impact, as you know now, resource depletion, and those mining activities and oil drilling activity has caused substantial damage to the bedrock structure at the bottom of the sea. All right, and that is why glass thimble filter is an environmental aspect. And another similar product of silica is the impinger bottle. It's a bit special. It is made from special materials, and it is an environmental aspect because it is an input aspect. We got to look at the upstream of its life cycle perspective. What is it made from and how does it come here? It is made from resources, fresh resources. It's not made from recycled plastic. Okay, it's not made from your recycled sofa. Okay, it is good glass, top-notch, high-class Pyrex. Okay, and they come from fresh resources, pure natural resources extracted out, and it interacts with the environment by causing resource depletion as the final environmental impact. And those mining or extraction or excavation of the ground causes geological damage. Okay, that is how they are environmental aspects. And remember, environmental management system is about managing all these environmental aspects by fulfilling compliance obligation and addressing risk and opportunity. Once, how do we manage them? Since they are environmental aspects, we have to draw good procedures, operational procedures for this particular activity, which is isokinetic stack sampling, from A to Z, from unpacking, planning of stack sampling activity until the activity is completed and back to the lab. There is an entire standard operational procedure whereby we would insert specific procedure to manage all these environmental aspects in a manner to reduce, if not eliminate, the potential occurrence of environmental impacts. And any way forward? Yes, risk and opportunity. We got to look at associated risk and opportunity. Okay, let's get to know the risk first. Please help me out if you have any additional notes here, because I've got limited space in this PowerPoint slide. Now, the risk. One of them, legal liability. On whom? This isokinetic stack sampling contractor? Yes, because we have got to ensure that our data is accurate. We got to be careful. If we are isokinetic stack sampler, I believe we know that we got to make replicates of our sampling and analysis. If our client, if this company has got the luxury to engage another company to do the same sampling at the same spot, same site, at the same production throughput, at the same efflux velocity of stack, and there are some variation in data, both the contractor can be questioned, and we got to provide accurate data. And if we don't, there is a legal liability there in the Environmental Quality Act itself. Okay, so we are supposed to have integrated. We need to have integrity in our work, and we have got to ensure that we are providing the best service, the most accurate sampling technique, and we have checked, double checked, and triple checked our sampling, our methodology. So it's not looping. This is what we cannot loop. It's not like some other processes when you are already the grandmaster of the work. You will start looping, and we don't do that, and I believe you don't do that. So this is the part where we got to be very careful. There is a legal liability associated to our work. And one more thing. As isokinetic stack sampling technician or engineer or the company itself, we are also susceptible to be called to court if this client of ours were summoned for any contravention to the Environmental Quality Act, especially air pollution. We can be summoned to court as a professional witness and to answer both parties, prosecution officers and also lawyers working on behalf of the company. We can be questioned in court. And we got to remember the date, time, the apparatus, name of technicians, etc. to that extent. Okay, that is the legal liability, which is not oftenly discussed with isokinetic stack sampling contractors. And I hope the purchase order given to us as the isokinetic stack sampler does not include clauses that states that your company shall also be responsible in giving statement in court at no extra charges. I hope. That can happen, but let's not talk about it. You might not want to hear it after all, but it's just a matter of discussion, but it has happened elsewhere. Okay, and equipment error. Why equipment error? Equipment is seldom error when we keep them in good condition all the while. We handle them with tender love and care, with all heart and soul inside it. Normally it won't amount to error. Even those battery operated, we got to make sure we follow the technical specification. It won't be an error. Equipment error is usually related to human error. Okay, and on top of this particular part is leakage, and we have got to perform leak test prior taking in the first legible sample. We've got to make sure there's no leak so that our data that we produce to our client is mint accuracy. Okay, we got to make sure that. And so therefore it comes to an opportunity that we can have something to look for in our environmental management system. I'm talking about assuming that this isokinetic stack sampling contractor is going for ISO 14001. This video might help you. So leak test is a standard practice, I believe, and you got to make sure the leak test equipment, even there are now a few equipment that do leak tests, make sure it's a good one, and the leak test is performed at a controlled known settings. Okay, and our work is an accredited our equipment is accredited by a calibration institution, legible enough, international recognition. Okay, and also in order to have a good stack sampling work done, we have to be preparing for the work up front. It's not like going to picnic. We got to check the equipment the day prior to the work. And I can't imagine if you are doing isokinetic stack sampling back to back in a day. Look, I've done this work before, okay, and it is tough, it is physical, it is very, very tiring. Sometimes we got to spend the whole day uh, in one particular factory to do a good isokinetic stack sampling, especially when the diameter is large. More traverse points are involved, and most sampling is involved, as you know, across the diameter. Okay, and if they have got two sampling ports, we've got to do two. Okay, two lines of traverse. Okay, so that takes time, and even preparing the equipment prior to the test, and of course bring it down and dismantling. You got to be very careful when you do isokinetic stack sampling, because the manufacturer has got SOPs. Okay, and when we are being called to court, we got to talk about technical stuff, and the prosecution has the luxury to bring in experts to listen to our explanation, and we will be asked left and right on technical terms. So you've got to be careful with that. And I wish you luck, and I wish you improvement in your work all the way. Now, I believe that is about it for linking safety, health, and environment. Do take some good notes of my warning, because I hope agencies are not listening to my video. I want all my friends out there who are fellow consultants, fellow trainers, fellow contractors on environment be having this knowledge first. Okay, now, so that's about it. I thank you for your attention. Thank you for your subscription and viewers and views. Okay, thank you YouTube. I wish everybody in bahasa Melayu semoga dikurniakan kesenangan, keselamatan, kesejahteraan, kebahagiaan dan kejayaan kehidupan. We all di dunia dan di akhirat. No, sorry, there's one mistake here. This is not resource conservation. This is actually not resource conservation. Please correct it. This is supposed to be what? Soil pollution. Please correct it. There's a mistake. All right. It is supposed to be soil pollution. So thank you very much. I wish everybody Assalamu alaikum wa rahmatullahi wa barakatuh. See you in the next video, inshallah.